Hello everyone. From chapter 15, structure of atoms and nuclei. A new article is wave number. So what is wave number first? Wave number means a reciprocal of wavelength is called as wave number. Now here, whatever the formula we are getting here, this formula is useful to explain hydrogen spectrum here. So let me obtain that formula. So for this article, we must have previous knowledge of the energy of electron article. Means we require this energy of electron formula. Now here, by Bohr's third postulate, we know that third postulate is electron radiate energy when it jump from higher energy orbit to lower energy orbit, and energy radiated in the form of photon, and which is equal to the difference in the energies of two orbit. Now I consider that electron jump from nth orbit to inner orbit p. Then we can write energy radiated is equal to En minus Ep. So where En is energy of nth orbit, and that I can write it by formula me raised to 4 divided by 8 epsilon 0 square n square h square. So this is the formula me raised to 4 divided by 8 epsilon 0 square n square h square. Similar manner I can write Ep minus me raised to 4 divided by 8 epsilon 0 square p square h square. So this I can write. So instead of n I written here p. So let me substitute these two in equation number 1. Hence equation 1 becomes, so E is equal to, I write this one, minus me raised to 4 divided by 8 epsilon 0 square n square h square minus this me raised to 4 divided by, so minus and this minus, so here plus 8 epsilon 0 square p square h square. Now after that we can take common from these two, and the common terms are me raised to 4 8 epsilon 0 and h square. So minus, no need to take minus common, so I directly write me raised to 4 8 epsilon 0 square h square 1 by minus 1 by n square plus 1 by p square. So these are the common terms. Now after that I can write here me raised to 4 divided by, so this is E, 8 epsilon 0 square h square, in a bracket I can write 1 by p square minus 1 by n square. So this E I can write, I write it here, this E is h mu. So mu is a frequency, h is a Planck's constant. Now this h mu I can write hc by lambda. So frequency is c by lambda. C is the velocity of light and lambda is the wavelength. So by using that I have to write a formula of wave number. Wave number means basically 1 by lambda. So 1 by lambda we have to obtain, so transfer h and c to that side. Hence 1 by lambda is equal to me raised to 4 divided by 8 epsilon 0 square, this c, and this h and h square is h cube. Then in a bracket 1 by p square minus 1 by n square. But here this me raised to 4 divided by 8 epsilon 0 square c h cube, everything is constant and it is called as R, Rydberg's constant. Its value is fixed. So this is a Rydberg's constant. Hence I can write here 1 by lambda is equal to R, 1 by p square minus 1 by n square. So this is expression for wave number. So I hope everyone understood this. Now after that, this wave number, we have to use this formula to explain the hydrogen spectrum. Now pay attention here. When electron jump from outer orbit to inner orbit, then energy is radiated Then if you find out the wavelength of that energy radiated, so we get a different range of the wavelength as per that energy emitted. We can classify this into several this energy is in the form of light. So basically, so if you find out the wavelength, then we get some light in the UV region, some in the visible region, some in infrared region. Based on that, we classified this series. So let's see a different spectral lines here. So when electron jump from outer orbit to inner orbit 1, then it is called as Lyman series. So I give the heading here, different spectral line, or so here we have some space here, so I write it here. So different spectral lines, and the first spectral line is Lyman series. Now Lyman series means what? When it is originated, when electron jump from outer orbit to inner orbit 1. So it means that here inner orbit is 1 and outer orbits are 2, 3, 4, 5 and so on. Now if I substitute here, hence 1 by lambda is R in a bracket 1 by P square. P is fixed, 1 by 1 square minus 1 by N square. N is having a different value. So N may be 2, N may be 3, 4, 5 and so on. If you find out the wavelength by using these 2, 3, 4, 5, these values of N, then we get a wavelength of UV light. So here we can write, so this, it lies in, this Lyman series lies in UV region. UV region of electromagnetic spectrum. UV region of electromagnetic spectrum. Okay. After that, second one, Balmer series. After Lyman, next one is a Balmer. Only the thing is here, electron jump from outer orbit to inner orbit 2. So it means that here inner orbit is 2 and outer orbit is 3, 4, 5, 6, 7 up to infinity. Then we can write here 1 by lambda is equal to R 1 by N square, sorry 1 by P square. P is the 2. So 1 by 4 minus 1 by N square. N may be 3, 4, 5, 6, so on. If we substitute these values, we get a wavelength of visible light. So we can say that this Balmer series lies in visible region of electromagnetic spectrum. Lyman, Balmer, then after that Paschen. Third one is Paschen series. Paschen series. Now here P is 3 and N is 4, 5, 6, 7 and so on. Then if you find out the wavelength, so we can write by same formula, hence 1 by lambda is equal to R 1 by P square means 1 by 9 minus 1 by N square. After substituting the values of N, then it is coming in the infrared region. Infrared region of electromagnetic spectrum. Similar manner, the fourth one is Lyman, Balmer, Paschen, then fourth one is bracket series. Now here you remember in bracket P is now 4 and N is outer orbit. If inner orbit is 4, then the outer orbit is 5, 6, 7 and so on. So here P is 4 and N is 5, 6 and so on. Okay. Now we can find out the wavelength, and definitely this is also lying in the infrared region. Then last one is P-Fund. So P-Fund series, again here P is 5 and N is 6, 7, 8 and so on. These are the values of outer orbit. Now here we can draw a hydrogen energy level diagram by using this. So here different energy levels we get. So Lyman series, Balmer series, Paschen series, bracket series, P-Fund series. So let me draw energy level diagram by using this. So next is hydrogen energy level diagram. Hydrogen energy level diagram. Or we can write energy spectrum for hydrogen atom. Now here, I consider here, you can see this is visible now. So here, N is 1. Now here, I keep some gap and write here, N is 2, second orbit. Then I am decreasing the gap here. N is 3. So again I am decreasing gap. N is 4. Now more less gap. N is 5. More less gaps. N is 6. And directly I am showing infinity here. So N is equal to infinity. Now this is first orbit. So energy is minus 13.6 electron volt. You know that energy of nth orbit is minus 13.6 divided by n square. This formula we already learned. Minus 13.6 by n square. By using that, if n is 1, this is the energy. If n is 2, then energy is minus 3.4 electron volt. If n is 3, then 13.6 by 9, so it is coming 1.54 electron volt. Minus, huh? So everywhere. Energy of fourth orbit. So 13.6 divided by 4 square is 16. So it is 0.84 electron volt minus. Energy of fifth orbit. 13.6 divided by 25 and it is coming minus 0.54 electron volt. And so on. Now here, when electron jump from this second orbit to first orbit, third orbit to first orbit, fourth orbit to first orbit, infinity to first orbit, this is Lyman series. Lyman series, and it lies in UV region. Then second one, you know that, Balmer series. So when electron jump from outer orbit to inner orbit 2, so it is Balmer series. Visible region. Then third is Paschen series. When electron jump from outer orbit to inner orbit 3, then it is a Paschen series. Paschen series. It is in infrared region. Then outer orbit to orbit 4, then it is bracket series. And outer orbit to orbit 5, P-Fund series. So this is energy level diagram for hydrogen atom. So this diagram is asked in in board exam many times. So you have to remember this diagram. So hydrogen energy level diagram. See this diagram very carefully. This is very important.